Good day, viewers. Welcome again to my channel, Second Matter, the solution to your math problems. We are still solving past questions on general mathematics, November-December 2024. This is theory optional question 8. Let's begin with the A. I read two consecutive even numbers are such that 1/3 of the smaller exceeds 1/4 of the larger by 7. Find their numbers. So let's represent the two consecutive even numbers algebraically. How do we do that? So I have with me here the first four consecutive even numbers. But we want to represent this algebraically. So if I represent the first even number as k, then how do I represent the second consecutive even number algebraically? That is in terms of k. I will see that from the first even number to the second consecutive even number, there is a difference of 2. So meaning that from 2 to get to 4, we need to add 2 to the first even number. So that should give us k plus 2. Again, from the second consecutive even number to the third consecutive even number, what do? We need to add 2 to the second consecutive even number. So for the second one, we are having k plus 2. So to get to the third one, we also need to add 2 to the second one. And this is simplified as k plus 4. So we have k plus 4 for the third. We can continue the pattern by adding 2 to 4, giving us k plus 6, k plus 8, k plus 10, k plus 12 in that order. But since we are looking for two consecutive even numbers, then should focus on the first two. So we can represent the two consecutive even numbers as k and k plus 2. So between k and k plus 2, which one is the smallest? So obviously k will be the smallest, or k will be smaller, and then k plus 2 will be larger. Now, can we write an expression for 1/3 of the smaller number? 1/3 of the smaller number. So 1/3 of the smaller number. What is the smaller number? The smaller number is k, and this is simplified as 1/3k. Can we also write an expression for 1/4 the larger number? So 1/4 of the larger number. So that will be 1/4 of the larger number. So the larger number here has been represented as k plus 2. K plus 2. Now, what is the relationship between the smaller and then the larger number? It has been given in the question. We're told that 1/3 of the smaller exceeds 1/4 of the larger by 7. So what does this statement mean? So now let's look at some scenario here. We have two numbers, 10 and then 7. So between 10 and 7, which one is larger? So we say that 10 is larger. 7 is smaller. 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 and then 7 is smaller. But we'll say that 10 exceeds 7. That is true. 10 exceeds 7. 10 exceeds 7. But what is the marginal difference? So we say that 10 exceeds 7 by 3. 10 exceeds 7 by 3. So how then do I write an equation between the two numbers? 10 is not equal to 7. That is true. But for 10 to be equal to 7, then we need to add 3 to 7. We need to add 3 to 7. So this can be written as 10 exceeds 7 by 3. 10 exceeds 7 by 3. That is what we have written. So with this same information, we know that 1/3 of the smaller, so 1/3 of the smaller is written as 1 out of 3k exceeds 1/4 of the larger. So 1/4 of the larger, we have 1 out of 4 multiplying k plus 2. By what margin? By 7. So plus 7. Now, what is our goal here? Our goal here is to find the two consecutive even numbers. So for now, let's solve for k. We see that we have a fraction here. So first of all, we need to eliminate the fraction by multiplying each term by the LCM. So what is the least common multiple of 3 and 4? So obviously that is 12. 12 is the least common multiple of 3 and 4. So now the first term, we have 1 out of 3k. So we need to multiply the first term by 12. So 12 multiplying 1 out of 3k. This should be equal to the second term. So the second term, we have 1 out of 4 multiplying k plus 2. So we multiply the whole of the second term by the LCM, which is 12. So we have 1 out of 4 k plus 2. And also the third term, which is 7, must also be multiplied by the LCM. So let me repeat this. So now, you see that 3 goes here, 1, 3 goes here, 4. So we have 4k. Also for the second term, 4 goes here, 1, 4 goes here, 3. So we have 3 multiplying k plus 2, and then 12 multiplied by 7. 12 multiplied by 7. That should give us 18. 4. So we can expand the brackets. 3 multiplied by k, 3k, and then 3 multiplied by 2, 6. So plus 84. So at this point, we can group like this. So in grouping like terms, we are grouping all terms containing the variable k on the left, and then all terms containing numbers on the right. So we have 4k on the left, then you transpose positive 3k to the left, it becomes minus 3k. This should be equal to 6 plus 84. Then 4k minus 3k, that is k. And then 6 plus 84, 90. So what are the two consecutive even numbers? So back to the introduction. We represented the first even number as k, so the numbers will be 90, and then the second consecutive even number is k plus 2, so that is 90 plus 2, which is 92. So that is it for the A. The two consecutive even numbers are 90, 90, 90, and 92. So 90 and 92. That is for the A part. Okay, so let's continue with the B. So I read, a solid cylinder and a sphere have the same radius, giving us R measured in centimeters. The total surface area of the cylinder is thrice as large as the surface area of the sphere. We have to find the ratio of the volume of the cylinder to the volume of the sphere. So let's quickly represent something. So we have represented the radius and the radius of the cylinder and the sphere as R. So now, the next step, let's find the total surface area of the cylinder. The total surface area of the cylinder. So what is the formula for calculating the total surface area of the cylinder? Total surface area of a cylinder. So recall that the total surface area of a cylinder, you're looking at a cylinder that is closed at both ends. Total surface area, 2 pi RH plus 2 pi R squared. So recall this formula. Now the next step, let's also calculate the total surface area of the sphere. So the total surface area of the sphere. Again, recall the formula. The formula for calculating the total surface area of a sphere. So the total surface area of a sphere is giving us 4 pi r squared. 4 pi r squared. Now, what is the relationship between the total surface area of the cylinder and the total surface area of the sphere? We're told that the total surface area of the cylinder is thrice as large as the total surface area of the sphere. The total surface area of the cylinder is thrice as large as the total surface area of the sphere. In algebra, the word thrice here means 3 times. So it is 3 times as large as the total surface area of the sphere. So what was the expression for the total surface area of the cylinder? So that was 2 pi RH plus 2 pi r squared. And this should be equal to 3 multiplying the total surface area of the sphere. And the expression was 4 pi r squared. So we can expand the brackets on the right hand side of the equal sign. 3 multiplied by 4 pi r squared, 12 pi r squared. Now we want to find the height of the cylinder. So for now, let's maintain 2 pi r h on the left, and this must be equal to 12 pi r squared. So minus 2 pi r squared. Consider we have some like terms here, so we can still simplify. So 2 pi r h is equal to 12 pi r squared minus 2 pi r squared. That is 10 pi r squared. So we have 2 pi r h is equal to 10 pi r squared. Since we are looking for h, we can divide both sides by the coefficient of h, which is 2 pi r. 2 pi r. So 2 pi r will cancel out, leaving h is equal to 10 divided by 2, that is 5. And again, pi will cancel out, leaving r squared divided by r. And that should also give us r. So meaning that the height of the cylinder is 5 times the radius of the cylinder. Now the next step, we have to find the ratio of the volume of the cylinder to the volume of the sphere. We have to find the ratio of the volume of the cylinder to the volume of the sphere. So the first step, let's find the volume of the cylinder. So the volume of the cylinder. Also recall, what is the formula for calculating the volume of a cylinder? So the volume of a cylinder is equal to the base area of the cylinder multiplied by the perpendicular height. We know that the base area of a cylinder is a circle, so pi r squared multiplied by h. But what is h in terms of r? We know that h is equal to 5 times the radius of the cylinder. So when you do the substitution, we are having pi r squared multiplied by 5r. That is in place of h, 5r. And this is simplified as pi r, this is simplified as 5 pi r cubed. So pi r squared multiplied by 5r. We have 5 pi r cubed. Let's also calculate the volume of the sphere. So the volume of the sphere. Recall the formula. Formula for calculating the volume of a sphere. So the volume of a sphere is giving us 4 out of 3 pi r cubed. So now we want the ratio of the volume of the cylinder to the volume of the sphere. Record of ratio here means division. Ratio also means division. So we are looking at the volume of the cylinder divided by the volume of the sphere. So for the volume of the cylinder, we had 5 pi r cube, and the volume of the sphere, we had 4 out of 3 pi r cube. So can we simplify volume of the cylinder, the ratio of the volume of the cylinder to the volume of the sphere? 5 pi r cube divided by 4 out of 3 pi r cube. So now let's focus on the numbers. 5 divided by 4 on 3. This is simplified as 5 multiplied by, we find the reciprocal of 4 on 3, which is 3 on 4. 5 multiplied by 3, 15 on 4. So for the numbers, we have 15 on 4. But see that pi r cube will cancel out pi r cube. So the ratio of the volume of the cylinder to the volume of the sphere, that is 15 is to 4. 15 out of 4 is the same as 15 is to 4. So that is it for question 8b. I hope you enjoyed this episode. Please drop your comments in the comment section, then share the video to your colleagues on other platforms to also benefit. See you next time.